To determine the arc length and the area of a sector, you can do it in two different ways. One is to use a formula, and the other is to think of it as part over whole equals part over whole. Now, when you use these formulas, you have to remember that theta has to be in radians, not degrees. It will not give you the correct answer if it is in degrees. So you take a risk with it. And for this formula here, the arc length, which is S, is equal to R times theta. That's derived from the equation of what a radian is. And the second one is where you have the area of a sector, which is equal to 1/2 R squared times theta. I like to do the proportion method because it makes more sense to me. And the proportion method is looking at part over whole equals part over whole. Arc length is to the whole circumference, as theta is to all the way around 2 pi. Same thing here. Area is to the whole area, pi r squared, which equals theta over 2 pi. Doing a couple examples. Find the length of the interceptor arc in a circle with a central angle measure of pi over 3 and the radius of 4 inches. So again, looking at the length of the intercepted arc, what I'm going to do is I'm going to go ahead and say that that intercepted arc is S. S is to 2 pi r, which is 4, equals central angle pi over 3 over 2 pi. Part over whole equals part over whole. Then I want to simplify. S is to 8 pi is equal to 1 over 6. You could think of that as pi over 3 times 2 pi, 1 over 2 pi. And at this point, you can multiply both sides by 8 pi. And therefore, the arc is equal to 4 pi over 3 inches. The next problem talks about a central angle. The question is find the length of the intercepted arc. Central angle is 125 with a radius of 7 centimeters. So again, I'm just going to set this up. S over 2 pi 7 equals 125 over 360 degrees. Notice you're talking about degrees here, and then you would solve it for your arc length. A couple more problems. Find the area of the sector. So what I'm looking for here again is the area of the sector. I always like to start with the unknown is equal to over pi 8 squared equals 60 degrees over 360. The benefit of this is you don't have to worry about always using radians. You just need to know it's over degrees. And then you would go ahead and solve for A. The last part, finding the area of the sector. Again, similar idea. A is to pi r squared, which equals the 2 pi over 3 all over 2 pi. And so that's a lesson on how to find the arc length and the area of the sector by using either formulas or by setting up as proportion.